Okay, question 13. Find the coefficient of x squared y to the power 4 in the expansion of 1 plus x plus y squared all to the power 7. Okay, so of course we're not going to do this by hand, right? Because surely it takes ages to expand. And we don't have, a trinomial expansion formula either. So how can we tackle this? So we need to borrow an idea from binomial expansion. So let me illustrate using a easier example. Let's say x plus y to the power, 6. So let's say I'm trying to find a coefficient of x squared y to the 4 as well, in this guy. So x plus y to the power 6 is x plus y and then 6 brackets, of course, right? So how do I make a term in this expansion? I make a term by picking in every bracket. I pick if I can pick x or y in each bracket, right? For example, if I pick x, 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 y, y, then I'll get x to the power 4 y squared, right? And that's one way of doing that. And of course, there are other ways of choosing such that you can also get x to the power 4 y squared, right? You don't have to force yourself to choose x's in the first 4 brackets, right? You could choose x in the first, second, third, and the 6th bracket, for example. Then the 4th and the 5th bracket will be y's, right? So the coefficient in front of x to the power 4 y squared is exactly a number of ways that you can choose your x and y's such that you get 4 x's and 2 y's, right? And that is exactly 6 choose 2 or 6 choose 4, right? If you say 6 choose 2, that means that you're choosing your y's, right? If you choose where your y's are, then the x are naturally, in the remaining places, right? If you go 6 choose 4, then you're looking at it in a different perspective, right? You choose all your x's, you put them there, and the remaining places are for the y's. So 6 choose 4, right? That's why the binomial coefficient exists. That's why the binomial formula is there, right? So now let's apply this logic to what we have here. So we have 7 brackets of 1 plus x plus y squared, so on, so on, so on. 1 plus x plus y squared, right? So if I need to make x squared y to the power 4, I need 3 of, so I need 2 of the x's, 2 of the y squareds, and then I have 7 brackets, right? So I need 3 ones. I need 3 ones, 2 x's, and 2 y squares, And then when I multiply them together, I get x squared y to the power 4. Agreed? Okay. So there are 7 brackets. How many ways can I choose my y squares? So for example, the y squared could be in the first and second bracket, first and third, first and fourth, so on, so on, so on. How many ways? Have a think. It will be 7 choose 2, right? You have 7 slots, essentially. You're choosing 2 slots for the y squareds to be. So 7 choose 2. Good. Now how about the x's? You have 5 remaining spaces, right? Because the y squares already take up 2 spaces. So 5 spaces, you allocate 2 for the x. So times 5 choose 2. Right? And then lastly, the ones go in the remaining places. Right? So 7 choose 2 times 5 choose 2. Right? Okay, you might say, well, what if I think of it in a different perspective, right? What if I put in my ones first, right? Then it will be 7 choose 3, I put in my ones, and then I have 4 remaining slots, right? So maybe I put in my x's, 4 choose 2, and then the y's go in the remaining places. Are these the same? Yes, they are. They're equivalent completely. So that's how you use the idea in binomial expansion and apply it to trinomial expansion. Now you can do like, when the bracket has 4 terms, you can even expand that because you know the general logic now. So we have to do the question still. 7 choose 2, what is that? That's 21. 5 choose 2, that's a 10. So 21 times 10 gives you 210.